Thanks everyone for coming out. Thanks Mark and Helen and Hannah for all the help organizing this. I see everyone got the memo not to sit too close to the philosophers. That's good. Glad that that's out there. Can everyone hear me okay? Great. I'm good at yelling. That's what my discipline trains us for. So what I'm going to do is start with talking about, well, I'll start with this example. Maybe. There we go. Has anyone seen this before? Okay, this is an image that was generated by Gemini, Google's image generation service, in response to the query, produce an image of 1943 German soldiers. And it produced this image, which if you can't tell, has one image that might fit the bill, but then there's one image of an Asian woman as a Nazi, a black man as a Nazi, and then an indigenous, plausibly an indigenous American as a Nazi. And this caused, pardon my language, a shitstorm. People were freaking out about this, yelling at Google, why is it doing this? And then Google said, you know, this is a misfiring of us trying to solve a different problem, which is that typically when you ask an image generation tool to generate an image of, say, a crowd, show me a crowd in a movie theater, it generates images that are predominantly white men. And they wanted to not always have it do that because that's not an accurate depiction of what a movie theater might look like. But in solving that problem, in increasing diversity in standard images, it messed with the generation of factual images, like historically accurate images. That itself caused another storm. Because people, another group of people then accused Google of being woke and trying to diversify their image tool. So Google, despite spending a lot of effort trying to solve this ethical problem, messed up. They did not solve the problem. It's a very hard technical problem to solve, but they didn't solve the ethical problem, and it produced either way, it was going to produce a problem. And this is not uncommon. This is not that recent. It's a couple years old now. But we continue to see over and over again ethical failures in this space, even among practitioners. Some practitioners just don't care about ethics. But even among practitioners and companies that are trying to do the right thing, we keep stumbling over ourselves. It's almost like we're walking through a field of rakes and we just step on every rake. And this talk is a bit about identifying some of those rakes and then diagnosing how we go about avoiding those rakes or clearing the field of rakes. I don't know which is the better thing. I guess getting rid of the rakes. But if you can't get rid of them, at least avoiding them. The plan for the talk is to go through what I'm going to call 4 pain points in the space of AI and big data. I'm going to talk in more detail about 4 specific pain points, 2 in much more detail, but these are the examples I'm going to use, or these are the pain points and the examples I'm going to use. So first, I'm going to talk about the misapplication of existing ethical tools. So sometimes we have an ethical problem in one space, we built a tool to solve that problem, or at least mitigate it, then we put it into a new context uncarefully, and it can't solve those problems in the new space. And so we think we're going to solve a problem, but we don't. So we often see that kind of mistake. Here I'm going to talk about privacy and informed consent, which are specific tools that we've used to solve a particular problem in human subject research. And we want to solve a similar problem in AI, so we brought them over and they failed. I'll talk about that in some more detail. The second kind of recurring mistake I'm going to talk about is what I'm going to call technical insensitivity. That's when people who have otherwise strong expertise in ethics or the humanities don't understand the technologies, like AI, that they're often theorizing about. And so they produce guidance or advice that's just the wrong kind of advice because they didn't understand how it was interacting with the technical system. And for that, I'm going to talk about the case of autonomous vehicles or designing autonomous vehicles to manage for accident scenarios. The third kind of pain point I'm going to call out is normative ethical insensitivity. And what I mean by that, just to be very clear, is not that people doing technical work don't care about ethics, but just like philosophers or humanists often lack understanding of the technical systems, there's lots of normative ethical expertise. And a lot of engineers, computer scientists, people in the sciences don't understand that. They don't have that expertise, so they build a technical solution to an ethical problem, but it's totally divorced from how an ethics expert would think about it, and so it solves the wrong problem in a different way. Finally, a kind of mistake I'm going to talk, and there I'm going to use the example of what's called algorithmic fairness, so I'll go through that in some more detail. The fourth kind of pain point is lack of stakeholder engagement, a failure to really engage with the communities for which you're deploying a technology, and so having that technology fail. And there's lots of ways that we fail to do good stakeholder engagement. I'm going to focus on a particular form, and the example I'm going to give is the Google Apple contact tracing app, and I'll fill you in on what that is if you don't know when we get there. So I'm just going to go through two of these in pretty quick succession, the first and the fourth. I'm just going to explain those quickly. Then I'm going to spend a little more time on technical insensitivity and normative ethical insensitivity because it requires a little more background to understand that kind of failure. And then I'll transition to explaining how we have been diagnosing these problems, how we have been looking for solutions, and then give you my preferred alternative, which is in the title, so it's no big surprise that what we need is what I'm going to call an ethics ecosystem. Okay, so let me first talk about the first pain point, which is taking toolkits off the shelf and using them in a new context and then having them fail. So I think part of what's going on here is, so in traditional biomedical research, we have these tools, informed consent and anonymization. Informed consent means something very specific. It means approaching potential research participants and meeting three duties. The first is a duty of disclosure, making sure that they have gotten the information relevant to the study you're trying to enroll them in. The second is a duty of informedness, making sure you've made a great or a good faith effort to make sure that they understand at least the crucial information from that enrollment, like what are the main risks to them and what are the main benefits. And then the third specific duty is non-coercion, like making sure that they don't in any way feel or perceive to be coerced into saying yes to enrolling in a study. It's like you cannot offer someone $1 billion to join a risky medical procedure. That's just too hard to resist. I would sign up for almost anything for $1 billion. So those are three specific duties. That's what informed consent means. That's a very particular understanding of informed consent, and that's what it means in traditional human subject research. Anonymization also means something very specific. It means anonymizing what are called personal identifiers, so name, birth date, social security, so you couldn't re-identify some anonymized person from the data and then track them, okay? So these are very specific tools, but they themselves we shouldn't care about. Informed consent doesn't matter for its own sake. Anonymization doesn't matter for its own sake. They matter because they're tools that protect more fundamental values. In the standard bioethics literature, what you'll see is that ultimately what we care about is showing respect for persons. And one of the ways we understand showing respect for persons is by promoting and protecting their autonomy. And then it's easy to see how informed consent can promote and protect autonomy and thereby show respect for persons. And the same for anonymization. If I can't figure out who you are or what sensitive information belongs to you, I can't use that against you or learn things about you that you wouldn't want to know. I also, if I get informed consent, I'm explicitly getting you to autonomously agree to participate in my research. Okay. But what's happened is that in the AI and big data analytics context, we want to solve the same kind of problem. That everybody agrees you should show respect for persons and promote and protect autonomy. Nearly everybody thinks you should show respect for persons and promote and protect autonomy. And so they said, oh great, bioethics has solved this problem. Let's just borrow their toolkit. Let's just make sure we get notice and consent and anonymization. It's called notice and consent because when you have a platform with millions of users, you can't plausibly sit down with them and actually make sure they're informed. But again, notice how that immediately makes the toolkit worse at promoting and protecting those values. Notice also that when you provide consent to platforms that you sign up for, you don't get the documentation in a way that's easily accessible to you. You get it as a legal document. Someone once calculated what it would take to read all the end user license agreements for the average amount of software on a computer, and it's something like 400 years. So it's not that you're all reading that and understanding that. So the tool no longer does the thing that it's designed to do. It's also not at all clear that it's not coercive. So many of you in your workplaces, especially if you're in academia, you're basically required to use a particular kind of software. It's like at Northeastern where I am, we use, unfortunately, Microsoft Teams. I don't get a say about that. I can't participate in my organization if I don't agree to give them a certain amount of data. And anybody that has a workplace platform that they have to use, it's not clear that it's uncoerced. Like, it's uncoerced only if you're okay with not having a job. For me, that counts as coercion. Maybe not as much as $1 billion, but it's pretty coercive. So these tools, when ported over to that context, fail to promote and protect those values. Anonymization is the same thing. Facebook does not need to know your name, your birth date, your social security number to reliably track you on the web, to make invasive inferences about you. It just doesn't need that information, so that tool doesn't work either. So that's one kind of failure we continue to see is take a robust ethics toolkit from one domain and uncritically apply it in the case of AI. Now let me say a little bit about lack of stakeholder engagement. The kind of lack of stakeholder engagement I'm going to focus on is a lot of people care about bringing participants into the design of their research, and that's can be important too. But I think one of the main failures is just failure to explain the way ethics is done or the way ethical considerations figure in to actually building responsible technology. So at the start of the pandemic, Apple and Google put their heads together and at the behest of states said, we're going to build a COVID tracking tool so that when if I test positive, I can click yes, I tested positive, and any device that was within range of me will get an alert that they were exposed. So it was contact tracing. Now, one thing that was really good about this is they spent a lot of time on the technical details, ensuring that neither Google nor Apple nor the states could get access to any of your location data. They could not tell where you were when you tested positive or who was near you or what state you were in or anything like that. You would get that information. It was all local and encrypted when it went to them. So they actually were very careful about protecting people's privacy because they knew people would be skeptical of this tool if not. Unfortunately, the way they explained those technical privacy protections was in a technical document that is, I spent 6 hours trying to read it to verify whether it actually did the things they claimed it did. Of course, Google and Apple are saying we built a privacy preserving technology, but Google and Apple always say that. And that's not usually true. So they did not demonstrate to individuals that they had actually done the work. They couldn't articulate in a way that was accessible and meaningful to citizens that they actually were taking their privacy seriously. And then so unsurprisingly, very few people trust Apple, nobody trusts Google, and a significant number of people don't trust states. And so they could not overcome the trust deficit. The way they explained their technical solution just was inadequate for them to overcome the trust deficit we have with those entities. So it failed, and lots of people died probably because of that. Okay, now let me transition to the sort of pain points I really want to focus on: technical insensitivity and ethical insensitivity. I'm going to start with technical insensitivity. To give you a feel for this, I'm going to talk about a practitioner example. Are people familiar with this case? Yes. Yeah? So some lawyer wanted to submit a legal brief. I don't know how much you know about the law. Hopefully not too much. It's not fun. When you're trying to convince a judge of something, what you do is you say, here's what's been decided in court in the last 500 years or whatever, and you cite a bunch of legal documents, a bunch of precedent and law. So some lawyer submitted a brief that he had generated with ChatGPT. And if you don't know this about ChatGPT, it's very important to know, it just makes shit up. It fabricated the citations. It's not even fabricated because it wasn't intentional. It just put together a random sequence of sentences that looked like legal citations. When I asked for what I've written to ChatGPT, you would be so impressed. The books I have written, according to ChatGPT, I'm an amazing scholar. I should have sent that as my bio. I'm going to start doing that. So the lawyer submitted it. The judge said, I went to look up this case law and I can't find it. And the lawyer's like, oh, I don't know. I just put it in ChatGPT. Because the lawyer did not know how the underlying technology worked. And so he didn't know that it was even a possibility that would completely fabricate the citations. He thought it was like a Google search, not like it was what we now call generative AI. So that's the kind of problem I'm thinking about, but I'm thinking about it not so much from the perspective of practitioners, but from scholars like me, who try to offer ethical advice about how to manage the problems of technology, but don't understand the technologies. So here's my example of that. If you haven't seen this before, this is an image taken from a website developed by the MIT Media Lab called the Moral Machine Project. The Moral Machine Project is a tool for attempting to gather people's opinions about autonomous vehicle driving scenarios. So these are autonomous vehicles, nobody is driving them, and the question it will ask you is, what should the autonomous vehicle do if it can't help but do one of those things? It's in an accident, and it's either going to hit the barrier or hit the people on the sidewalk. I won't go into I'm happy to talk about the Moral Machine Project in the Q&A, but this is just a nice example of a literature and discussion that emerged when autonomous vehicles were sort of starting to be proposed about the relationship between so-called trolley problems or trolley cases in the philosophy literature and autonomous vehicle accident scenarios out in the real world. For the first time since Aristotle, people were calling up philosophers and being like, hey, don't you have a thing that you guys always talk about that's like what autonomous vehicles might be in, like car crashes that you might have to decide between killing one person and saving 5 people or whatever? And philosophers, we jumped at the chance. We were like, yes, we have a problem just like that, and we can use that tool to help solve your problem. So a ton of articles sprouted up from philosophers trying to explain how to use trolley cases to solve for this specific problem. And then of course there were skeptics too. So there's a whole literature both in the pop media and in the academic literature on this problem. For those that don't know, a trolley case is just imagine a train is running down the tracks. It's going to hit 5 people. There's a bystander who could pull a switch. If they pull the switch, it'll divert the trolley or train onto a different track where it'll only hit 1 person, should the bystander pull the switch. That's one version of a trolley case. So you can see how you might have an autonomous vehicle accident scenario that looks a lot like that. Just imagine there's only 5 people there and only 1 person in the car. But okay. So why is this inapt? Why is this problematic? Why does this show a kind of ethical insensitivity, or technical insensitivity? To see that, I have to talk a little bit about programming. I'm sure you didn't sign up for that. I'm sorry, but we're going to do it anyway. There are 2 ways to think about how algorithms are created. One is what I'm going to call the traditional paradigm for creating an algorithm. An algorithm is just a set of instructions getting from an input to an output. A cake recipe is an algorithm. You get, I actually don't know how to make a cake. Eggs, flour, chocolate, that's got to be it. Yeast, maybe, I don't know. You do something to them, and out comes a cake. That's the thing that tells you how to go from the raw ingredients to the cake as an algorithm. There are different ways you can create those computer algorithms. On the traditional model of algorithm creation, a programmer hand specifies or writes out the recipe. Or in the case of big software like Windows, a team of programmers writes the recipe. But what matters is, on the traditional way of thinking about algorithms, for each input, you're going to hand write how that gets translated into an output. Right? When someone pushes this button, when someone pushes the A key, have an A pop up on the screen and have it do this or this or this, whatever. Move the cursor over one thing. Okay. That's one way to build algorithms. A second way to build algorithms now is what we call machine learning. That's another paradigm for building algorithms. Instead of having a programmer or set of programmers hand write recipes, what you do is you provide what's called a learning algorithm with a data set. And you say, hey, I want you to write a program that helps translate these inputs to these outputs. So for example, you might say, here's a pile of email. These ones are spam and these ones are good. Can you please write an algorithm that will predict for the next email whether it should be classified as spam or whether it should be classified as a good email? And then what I'm going to do is hand code, if something is marked as spam, put it in the spam folder. If it's marked as good, put it in someone's inbox. Like that's the hand coding. That's the traditional part. Okay. So here's why this is important. Couple reasons. One, you cannot build an autonomous vehicle using the traditional paradigm. It's impossible. It's impossible for programmers like us, and not me. I mean, like the good ones. I'm not actually good at programming. Why? Well, it's not hard to tell a car, don't cross double yellow lines. Like that's easy to hand code. What it's very hard to get an algorithm or get a programmer to code is to tell when a thing is seeing double yellow lines, or when an object is a stop sign. Like for us, that's just natural. We don't have an easy coding language that's like, when you see a 5-sided polygon, that's a stop sign. Like we just don't have that. So what we do is instead program the image recognition systems in these cars by feeding them millions and millions of images of stop signs and millions of images of speed limit signs and millions of images of yield signs, and we label them, and then we have it do that classification. It figures out what the algorithm looks like. So there's just no way for us to code in object recognition in the robust kind of way we would need to make autonomous vehicles possible. There's plenty of hand coding that happens on the traditional paradigm, but image recognition, object recognition is a machine learning problem. Okay, so why does that matter? Well, here's why that matters. When you want to get behaviors in particular situations in the machine learning paradigm, you do that through your training regime. You don't get to say, I want you to do this in this circumstance, and this in this circumstance, and this in this circumstance. Instead, we have to build as a training regime that gets it to do all the tasks that it cares about. So for example, being able to recognize stop signs is also part of being able to recognize when there's someone in the road that you don't want to hit, versus being able to tell when that thing in the road is a cone versus a baby carriage. Like you have to do all of that at once in the object recognition training. Okay? But what that means is there's no programming for what to do in this one accident scenario differently from what to do in this accident scenario, differently from what to do when it's not in an accident scenario. So the ethical question is, given that I have to train my car to behave in all these scenarios, how should I go about doing that? Which is very different than the way the philosophers were thinking about it, which is like, in this scenario it should do this, and in this scenario it should do this. So the ethics questions all happen back there in training as opposed to there in particular scenarios. We can't treat them independently. And so by not knowing that, we spent a lot of time articulating what a car should do in particular scenarios. That engineers could try to do that. They could make a car that was really good at navigating accident scenarios, but there's every reason to think that that would make it worse in all the everyday scenarios that it's typically in. Because now it's paying attention to different features, like making sure it hits one person instead of 5 people, instead of making sure it stops at stop signs. So this technical insensitivity led to bad ethical advice. Okay, now it's time for the engineers' comeuppance. The other side of that coin is technical practitioners that have inadequate understanding of ethics, and so build ethics tools, technical ethics interventions to solve an ethics problem, but it's actually not quite good. There are lots of examples of this. The most widely known and widely discussed has to do with algorithmic fairness, which is what I'm going to focus on. This box, I'm not an artist. This box just represents the literature on algorithmic opacity, which is algorithms that we don't understand. We build them with machine learning, but if you provide enough training data, it will become impossible to tell what's going on underneath the hood. Like, no program can figure out how it's translating inputs to outputs. Like, the algorithm will just be a mystery to us. And this problem happens there too. It happens in the technical privacy literature. But we're going to focus on algorithmic fairness. This issue blew up in the literature after the release of an algorithm, or what we call a model typically, by a company called Northpoint. And the model was called Compass. And what Compass did was you fed the model details about people's criminal history and some other details, and it made a risk prediction. It either assigned them, it gave them numbers, but they were classified either low risk or high risk. What it was used for, not what Northpoint said it was supposed to be used for, but what it got used for was making predictions about, or used in decisions about whether to hold people who are arrested for pretrial detention. So someone gets arrested and we're trying to decide whether to release them on bail until their court date or not to release them on bail until their court date. And judges, parole boards, people making these decisions were relying on Compass to assign them a risk score for how likely they were to recommit a crime. If they had a high risk score, then that meant they tended to not hold them for pretrial detention. If they had a low risk score, they would let them out, roughly. So that's what it got used for. It will probably not surprise you to learn that when ProPublica is a public open access news source, did an analysis of Compass's algorithm, or the Compass algorithm, and they found that it disproportionately labeled black defendants as high risk. That's in some sense unsurprising that it would be biased in that kind of way. But this started a big fight because what they said was that Compass had a higher false positive rate for black defendants, meaning it more often labeled them as high risk, and then even if they were released, they weren't rearrested. So it mislabeled them as high risk and they didn't recommit crimes. It had a higher false positive rate for black defendants than white defendants. Also for males over women. Men over women. And then Northpoint responded and they said, yes, it's true that it has a higher false positive rate for black defendants. But our algorithm is not just, we just didn't make the most accurate algorithm, we actually calibrated for fairness. And calibration means something very specific. It means that for any given risk score, the chance of reoffense is the same independent of, say, race. So if you got a 6, no matter your race, you had the same percentage chance of recommitting a crime. Let's just say it was 60%. That's not true, but let's say that. So they said, our algorithm is calibrated, and ProPublica said, yeah, but it's got higher false positive rates. And then what some people were pointing out, and they both knew this, you can't have both of those. You can't both calibrate your model and have it have equal error rates. It's just, there's a technical, in most circumstances, you just can't have both of those at the same time. And so this started a huge fight in the literature on how to manage fair algorithms and which fairness metric is correct. A fairness metric is one, equal false positive rates is one fairness metric, calibration is another, and there's actually just a ton of them that you could deploy. And so this started a fight. What's the right fairness metric? Should we care about calibration? Should we care about false positive rates? What should we focus on? And that's a debate. And then people were building algorithms and deploying those fairness metrics in various ways on their models and then trying to advocate for their favorite fairness metric. But this just misunderstands the normative issues of fairness that we should care about in several ways. So first, one important factor about fairness is that there's multiple types, and which type matters is context sensitive. So one kind of fairness we care about is what's called distributive fairness. That is, when you're going to distribute some benefit or some burden, some cost, you should distribute it fairly. But that's very different than another kind of fairness, which we call procedural fairness, which we want to make sure a process is fair, independent of the distribution of outcomes. Okay? So think about criminal trials. We're not like, we should assess criminal trials and make sure they're giving an equal number of guilty verdicts and an equal number of innocent verdicts. No, we want fair trials. And if it results in lots of innocence, that's great. And if it results in lots of guilty, I mean, that's maybe not so great. I mean, something bad about our society is going on. But what we want is that process to be fair, not the distribution of outcomes to be fair. And then a third kind of fairness is restitutive fairness, like making up for when we've been unfair in the past. How do we make up for that in the future? Like maybe distributionally, we disproportionately advantage certain people in the past. So how can we recompensate for that in the future? That's a different kind of fairness still. So one thing to just wonder about Compass is fairness metrics are about distributive fairness. Are we distributing results in the right way so we're getting equal positive rates, or so that people have an equal chance no matter what their label? But you might strike you as thinking like, hey, shouldn't parole decisions be like procedural fairness, like criminal trials, and we shouldn't care about the distributions as much? But then you're just deploying the wrong kind of fairness. But even if you think you should be thinking about distributive fairness, the context matters a lot. So now I'm going to tell you what North Point said the algorithm was for. It was supposed to predict, a high risk score was supposed to mean that keeping that person from reoffending would cost more resources than someone that had a low risk score. But there are lots of ways to spend resources to prevent reoffense. I guess one of them is holding people in jail. But another one is providing money to communities, providing after-school resources. There's all sorts of allocations you could give that would help people that were high risk score not to reoffend, that aren't keeping them in jail. Now notice how these questions have very different judgments about whether it's fair or not. I'm going to label high-risk defendants that are black defendants are going to be disproportionately labeled high risk, and we're going to thereby hold them for pretrial detention at a higher rate. That sounds obviously unfair. This sounds way less unfair, it's at least an open question. Black defendants are going to be labeled high risk at a higher rate, but what that means is we're going to send more money to black communities to prevent offense. Maybe that's unfair still in some way, but it is a very different kind of fairness question, and whether you think the algorithm is unfair depends on the context. So not thinking you can develop a fairness metric that makes things fair is just insensitive to that. A broader point that I think is also extremely important is that we need to think about the socio-technical aspects of these systems. Nobody should care about fair algorithms. Algorithms do not make decisions. Someone makes a decision. They might get information from an algorithm, but it's parole boards and judges that were making decisions. We should care about fair decisions, not fair algorithms. But then the question isn't how do we install a fairness metric that makes this algorithm fair, it's how do we think about making a judge that's getting an output from an algorithm make fair decisions. And here's another thing we learned about with Compass, that when you gave a judge the same risk score for a black defendant versus a white defendant, they were much more likely to let a white defendant go on pretrial detention than a black defendant, even when they had the exact same risk score. So it was not resulting in fairer decisions. So not recognizing this led to a bunch of, I skipped a slide, but that's okay. There we go. Okay. Okay, so what's the upshot of that? What are some lessons we might take away from those pain points? You might think, well, it's important that people theorizing about these things understand the technologies over which they're theorizing. It's important that we develop technical solutions that aren't free from ethics expertise, that ethics expertise is sort of grounding the technical solutions we develop. We should think carefully about the context of the technology and develop context-sensitive solutions. And we should think about socio-technical systems instead of simply technical systems. We should think about fair decision systems rather than fair algorithms. And we should really engage key stakeholders. No. I mean, yes, I like all those lessons. But that is not what we should take away. You could not possibly achieve the things we care about by trying to make those the general lessons. I have met lots of computer scientists. It's hard to get a PhD or an MA or even a bachelor's or BS in computer science, then telling them, hey, you've also got to go get a degree in philosophy. I mean, it's really good for my discipline, so yeah, let's do that. But no, that's not a realistic solution. And I've met enough philosophers to know you're not going to train them all to understand computer science. And importantly, and that's not the only stakeholders you need to cross-train and make interdisciplinarily aware. Importantly, that is not how we solve ethics problems involving other technologies. We build what I'm going to call an ethics ecosystem, a robust set of components that distributes the work of doing ethics. So what I'm going to do is talk about each of the components of such an ecosystem, and then I'm going to transition, and then I'm going to give some concrete examples. So the components I think are most important are this: ethics infrastructure. That is the local day-to-day tools that everyday practitioners can be trained to use and follow even without knowing a ton of ethics. It consists of things like simple rules and checklists that include things on a checklist like, hey, you'd better go get some more help because you're in real trouble. It also includes things like local oversight, people monitoring and making sure that people are following the rules. Another key component of the ethics ecosystem is what I'm going to call ecosystem governance. That's the policy, laws, and regulation that reinforce that local ethics infrastructure. They say, here's the punishment for violating this. Here's the benefit you get from following the rules. Education, training, and outreach. That teaches people how to follow those rules. It's the training you get to follow the ethics infrastructure, to use it, to deploy it, and also the tools to educate people about the ecosystem so they can come to trust that ecosystem. Fourth component, foundational to translational research. No ecosystem is perfect. There's always edge cases, there's always ethical challenges. We need people constantly thinking about how to make the ecosystem better, how to solve foundational problems, and then how to translate that into better governance, better ethics tools, better education and training. So that's the foundational to translational research. The middle component, the sort of central two components, are one, a shared set of language and concepts so that people in the ecosystem can talk to each other easily. And then the other part is interdisciplinary practitioners. We do need some people to learn all those lessons I mentioned, and they can serve as a foundation for translating across the different components. There's also two, I think, features that are worth calling out, features and functions. One is that in a good ethics ecosystem, these parts are coordinated. I've already described it that way. The laws, the rules, the governance reinforces the infrastructure, and the education does the same, and sometimes the governance will mandate certain educational requirements. So there's a coordination between all the components. And then one of the best features of a good, or functions maybe, of an ecosystem is that it enculturates the people in it. They start to see the world through an ethical lens of the ecosystem in which they work. The ethical problems of the space are sort of like, just appear to them in a particular kind of way. And this will be clearer when I give my example. So what I'm going to do is walk through these components in the space of healthcare and compare that to AI and big data. Healthcare and medicine and health sciences actually has many distinct ethics ecosystems. There's one for human subject research. There's a separate and robust one for animal subject research. There's one for clinical care. And there's one for embryonic stem cell research, which is still its own thing. I'm just going to focus mostly on human subject research. Also, I'll point out other domains have ethics ecosystems. Aviation, military, business, law, they all have ethics ecosystems that have these components. I just know more about the bioethics one than I know about the other ones. So in the case of ethics infrastructure in the healthcare space, if you are a practicing scientist that does regular human subject research, you are trained how to fill out a protocol that specifies all the components of an informed consent procedure. You are then know that you have to submit that to an IRB who is trained to evaluate that to make sure you're following those 3 duties that I mentioned earlier. Like, this is just part of the procedure you're trained to do. You don't have to learn a ton of ethics. You do get a short history course on like why we have the ethical rules that we do. But the training is not, it's part of your standard schooling, and it's a standard set of tools. They're easy to follow rules. You get checklists. There's like flow charts for how to fill out the protocols, things like that. In the AI and big data space, the closest thing we have in the United States is called the NIST AI Risk Management Framework. It's a really great framework. It's awesome, but it's very high level. It like covers lots of values. No computer scientist, no, I won't say no because I know some that can, but almost no computer scientist could actually use it to figure out how to govern their own work on a day-to-day basis. There's no flow chart that tells them like, here's how you make an informed decision about this particular programming choice. That just doesn't work like that. Policy and regulation. All the stuff that I said about IRBs and local oversight, it's embedded in the law. It's called the Common Rule. Same for the Animal Welfare Act with animal subject research. In the US, we had just an executive order, so not a law, that established the AI Safety Institute. That executive order was rescinded on the second day of the Trump administration, so there's nothing in the law really right now in the US. EU's got something a little better, but we can talk about that in the Q&A. In the healthcare space for outreach, training, education, it's just mandatory. Like as soon as you declare pre-med, you start getting bioethics training. That just doesn't happen in the AI and big data ethics space. There are curricula for training ethicists. We do that at Northeastern. Harvard does it. It's a very small number of institutions that do it. And I promise you there's no coordination. There's no teaching about the NIST ARMF in that training. Whereas in the bioethics training, you're trained about IRBs and how to carry out various protocols. Research programs. In the healthcare space, these research programs are robust. There are case study libraries. There are meetings of IRBs. You can get a job as a bioethicist. You can go to school to become a bioethicist. There's like a whole research field for research and exchange. In AI and big data, we're starting to get journals. We're starting to have conferences. The biggest one is called FACT, Fairness, Accountability, and Transparency in AI. Thousands of people go to this conference every year. And it's from all disciplines. And then the philosophers go hang out with the philosophers, and the social scientists go hang out with the social scientists, and the computer scientists hang out with the computer scientists. So we don't have that kind of robust interdisciplinary research program. Shared language and interdisciplinary scholars. There are bioethicists, I just mentioned that. And informed consent means a very specific thing. In the AI and big data space, every time I get in a room with a computer scientist to talk about fair algorithms, we have to spend an hour just making sure it's mean the same thing when we use the word fairness. And the same for transparency, and the same for everything else. Then they have to make sure I understand things about AI because they're like, do you actually know what you're talking about? It's a good time. And there are very few AI ethicists. You could not fill this theater with AI ethicists. You could fill Manchester with bioethicists. Okay, so how do we get there? I'm going to say something very brief. It's very hard to think about how to build this ethics ecosystem. One thing we can do, this is part of a project I'm on called the National Internet Observatory. The National Internet Observatory asks people to give them their internet data so that researchers can study how the internet influences behavior. So how do platforms give you ads to shape your behavior? So we ask participants to give us very sensitive data about them. But here's the thing, IRBs weren't built to solve this problem. And so once we have your data, when another researcher wants to access it, they're not bound by an IRB. They are under no ethics governance whatsoever. So we had to build an entire ethics infrastructure, and we adopted this ecosystemic model. So even though there's not a robust ethics ecosystem for the field of AI and big data, we can build it for specific projects. If you want to look up this paper, you can see this chart we built about all the different values we're trying to capture and how we built mechanisms to do that. But in general, I want to trying to wrap up quickly, I don't want to eat too much time. I want to draw attention to what it means to think and act ecosystemically, lessons that we might, as academics, as citizens, take to bear in thinking about this problem in this way. So first, if we're in any way contributing to any one of those components, we're building research in AI and data ethics, or we're building educational tools in AI and data ethics, or we're building governance tools or policy tools. We should keep an eye on what's going on in the other parts and try to coordinate. Like now that I've been thinking about ecosystems for long, when I teach students about AI ethics, I'm like, there's this framework called the NIST AI Risk Management Framework, and you should think about how to take your philosophical skills and build out that framework, because that's going to be the framework that governs a lot of the space. So it's useful to make sure that we're doing what aligns with the government is telling people they should do. Develop local ethics ecosystems. If you have the chance to sort of think through the ethics, or you're doing AI and big data work, and you can build an ecosystem just for that project. Try to build all those components, build up regulation just for that project, build up operationalizations and tools just for that project. So you can build an ecosystem locally. It doesn't have to be a massive global thing. At the same time, you can advocate for a broader ecosystemic intervention. You can say, hey, my company, we're doing this, and we actually need more legal guidance. Don't just say you need legal guidance. Say, we need all these tools. Please build and coordinate these. This is what would help us get our work done. And then I think a really key thing for us to do is to showcase the ethics ecosystems we're building and contributing to, and articulate how they promote and protect key values. We need citizens to understand the tools we're building and that they're protective of them. Otherwise, they're going to remain skeptical, and we're going to continue to face the COVID contact tracing problem, where we build a tool, we actually do the right thing, we've taken ethics seriously, and nobody uses it, and no one's on board, and we just don't gain trust. So we have to actually showcase, not that we've built one ethics fairness metric that's going to make people happy, but that there's a wide system, a Swiss cheese model of protections for citizens. Okay, thank you very much. I'm now going to field questions, but I'm just going to call on people. Yeah, we're doing one at a time? That'd be great. Okay, great. Yeah, I know about the IEEE one. I think that is like the NIST AI risk management framework. It's not quite as robust, but it's still pretty high level and not very operationalized. For good reason. We don't know what specific operationalizations we need, and every project might be different. So it's a kind of thing that's out there. Like, every company has their commitment to AI. It's better than this. Every company will say, we care about fairness, transparency, safety, which is great, but it doesn't tell you how to do anything. The IEEE is more directed than that, but it's not so directed that the average computer scientist can say, I actually know how to do this in any robust way. So that's my worry about it. But it does fit in. It's a piece of that. It's a piece of infrastructure. Yeah. Yes. Yeah.
Doesn't this impact profits?
Hard to know. Given people's tech skepticism and growing tech skepticism, it could be a real selling point that we can showcase that we have a robust ethics ecosystem that's protective of these things. But it's an interesting question about whether or not, this is the point about enculturation that matters. Within healthcare, almost no one would say, having this ecosystem impacts profits, so can we get rid of it? Instead, they think about how to maximize profits within the ethics ecosystem. That's the marked difference between domains that have an ethics. Nobody in aviation is like, we should get rid of safety audits. But that would save money. So I think that that kind of, I get the point of the question. And I think that even if it were costly, the only reason we think that that's a mark against it is because we don't yet have the ecosystem. But here's the bad news. An ecosystem is going to come. We're going to eventually get regulation, or we're going to adopt some status quo. The question is just whether we get a good one or a bad one. And right now, if we let the companies that care most about profit direct the efforts, we're going to get one that's not great for us, sadly. Yeah. Yeah. It's an interesting question. One of the things I typically say about that is there's a lot of people interested in, like, how do you embed ethics in AI systems? And I often think that's the wrong question. The question is, how do I build AI systems ethically? And it's a question whether that means instilling ethics in them at all. So like in the autonomous vehicle case, what I don't want is a car that makes ethical. I don't want it to sort of say, like, should I behave like a utilitarian or not? I want to say, should I behave like a utilitarian or not? And then just program a car to do to either maximize utility or not. So I'm sure that there is at least a short-term market incentive for trying to develop, for example, AI agents that sort of have your values. So there's lots of short-term market incentives, but if I'm not sure there'd be a long-term market incentive because it's not clear that's the right ethical approach. You know, that's a hard problem, but it is a problem we've overcome in lots of cases, right? Aviation, bioethics. We won't get perfect agreement. Some people will disagree with lots of things. But I think there are both, at the individual corporate level, for example, where there's no, except for being consistent with the law, I think it's okay to bring in experts even if people won't agree with them. At the state level, the way we manage these things typically is that we have processes for legitimating decisions even when people don't agree. So the NSF just makes decisions about which science to fund. NSF used to just make decisions about which science to fund. And the way they got the authority to do that, even though people might agree with them, is that we elect a government that then they just choose which experts then make sets of decisions. And that's how the National Highway Safety Transportation Authority works. Like, we just say, like, hey, do we have a legitimate interest in appointing an expert to make these kinds of decisions? That's what happened with bioethics. When the story of bioethics is there's different stories for animal subjects and human subjects, but take animal subject research. Pharmaceutical companies were just kidnapping dogs and using them in research. And someone said, we're going to put a stop to this. They put some people in charge. They said, get the most important experts in bioethics around and have them make a set of rules that they then propose that then get voted on. Same happened with human subject research. There's a bunch of violations of human rights. The National Bioethics Council was formed. They said, you're experts on bioethics, take account what the public says, formulate a set of rules, we're going to pass it as a law. So I think there are processes in place to navigate disagreement, and we've done it lots of times in the past. Will we end up with the set of laws that I most like? Definitely not. These are always compromise situations. So like if you put me in charge, like Plato's philosopher king, what we'll get is very different than if we use democratic processes. But I think that there is a way to find agreement or find a position that's legitimate even though you won't have total agreement. So I think a process like that is what we'll have to do. Yeah.
Marry the two in any kind of easy way.
Well, not in an easy way, but you can marry the two. We make decisions about whether to trade off efficiency for ethics all the time. And sometimes we think that I think efficiency is just an ethical consideration, right? It is a benefit you can get. So is respecting autonomy. So is respecting privacy. Those are just all values. And the question is sometimes accuracy a value that's worth having at a cost to the others? And the answer is sometimes yes, and sometimes no. And so we just have to decide which computer use cases are such where we want the accuracy trade-off. So like, here's the thing. It may be that medical diagnostic tools will be biased in certain ways, and we might say, but we'll take the accuracy in that context. But that's not what we want in the criminal justice system. We care a lot more about doing the right thing there than being accurate because, we already have set up the system not to be accurate. We want to presume innocence. That's already saying, throw accuracy out the window at first, presume this, and then prove the other way. So we can make context-sensitive decisions about when efficiency as a value should win out. And we do that in every industry. So it is a trade-off.
Another way to put that is to say sometimes efficiency is not the most important value.
That's exactly right. Sometimes accuracy is not the most important value. And sometimes the right trade-off is giving up accuracy for a little while to get an accurate system later that is a better balance of our values. And I would say that is true in, despite the hype, lots of AI, you'll hear tons of claims that AI is more accurate than doctors, for example, that it's better at diagnostics. It's almost never true. What it means is that if you give a doctor the same exact test as the AI, you just show it an image, that the algorithm is more accurate. But doctors don't just look at images. They can understand all sorts of things that algorithms can't, and they're actually much more accurate than models. So when you give a doctor not just the scan, but the patient history, let them talk to the patient, let them do other things, they crush the models. And the same has largely been true of large language models, which do good on very narrow benchmarks, but actually fail in real-world tests in all cases. So a lot of the accuracy claims are slightly overhyped, but it is just one value among many. Yeah. Yeah. Hi.
So what he's saying
Yeah.
is true.
Yep. Okay, so I want to say a couple things. So first, one thing you might say is that, well, we didn't used to have that in those other places, and we just mandated it by law. And so we could just think that that's a necessary condition in the case of AI and big data. I'm not quite sure of that, and I'm not quite sure of that for two reasons. One, first of all, computer scientists are ingenious at developing auditing tools that require less data. So you might be able to come up with auditing systems or create private clean rooms where the person auditing gets the information, but it's not at a corporate disadvantage. So you might be able to develop technical solutions that don't come at a cost to the companies. I'm not sure. That's a technical and interesting challenge. We do have one very good example of a case where we didn't by law have a mandatory ethics ecosystem, but it still ended up being very robust. At the start of, during the George W. Bush presidency, the government just decided it was not going to fund embryonic stem cell research. It just said, we're not going to fund it. And so therefore they said, we're not going to provide an ethics toolkit for you. National Academy of Sciences brought together key people from industry, from academia, from practice, and they just built the full ethics ecosystem. It wasn't grounded in law, but instead everyone agreed we're going to have these kind of review committees. Here's how we're going to do audits. Here's how we're going to do that kind of thing. So, and part of that has they came from bioethics and already had an ethical foundation. We don't have that in computer science right now. But I do have some hope that I teach a lot of junior computer scientists and they want to do more ethics. I could see building from the ground up. It'd take a long time, but an internal community of people that just said, like, we're just going to do this. If you want to hire the best talent, you're going to constrain yourself to these kind of auditing techniques. Or we want to make sure that when you put out a product that's privacy enhancing, that's been verified by a third party. Maybe that's a service that we can sell too. Like, you can put a label that you're privacy preserving, and that gets you more profit. One other thing I'll say is that, like, unlike other spaces, the community of computer science around AI, almost all the cool results become public almost immediately. Like, doing things, DARPA has basically given up doing private machine learning just because the community of computer scientists share things so rapidly that it's pointless to try to keep things hidden. So there's some hope, I think, in this like tight commitment to open sourcing things that gives us some hope of being able to audit at least some level of technical techniques. Yeah, but it is a problem. Yeah, great. That's my main area of research, is on explainable AI. This is another case where people have been there's lots of ethics and sensitivity. So for those that don't know, there are these models that are so complex that even programmers don't know quite how they work. This has freaked people out. And so there's a whole area called XAI, where the goal is to develop new tools that help figure out what's underneath the black box. And like, people are like, it's not fair to make decisions about people that they can't understand. So then computer scientists are like, well, we can solve this problem. So what they do is they build another model that makes predictions about what the underlying model does. It's an ingenious technical solution, but of course doesn't speak to any of the things we actually care about. So a lot of my work is about explaining why should we even care about explainability, and what would it mean to actually build XAI tools that made things explainable in the ways we care about. So I think there's lots of work to be done, just like in the fairness case. But I do think it can be done. I think there are some cases where it's just not okay to use a black box model. Court decisions, risk, in the Compass algorithm was not it was a black box only because they wouldn't tell us how it worked, speaking to your kind of concern. But it wasn't a black box in that it was so complicated we couldn't understand it. But there are, like large language models, we have no idea what's going on under the hood. So it's a problem, but it's, I think, the same kind of solution. You pick a context, a particular kind of use case, you ask what are all the values that are relevant. We want the benefits. People seem to want the benefits of large language models. I don't quite get why. Less emails, I guess. But it comes at a cost to explainability. It comes at a cost to fairness. It's because it advantages certain languages over others. How do we trade those off against one another? And in that context, we can maybe come up with a solution that balances those values correctly. Complicated. I actually don't think, so I think this. I think when you're using AI in medicine, the appropriate approach is not to let a diagnostic tool make a prediction that you then share with a patient. The appropriate use of black box AI in medicine is that you use these tools to inform a doctor as part of their total evidence. So they say, this diagnostic tool made this prediction, the case file says this, the patient says this, the referring doctor says this. Now it's my job to make an informed decision. If it's a black box model, it makes it harder for me to know how it was deciding, and so then it's harder for me to decide how to take it into my evidence pool. And so but then I can just, let's say I do know how it works. I can then get informed consent from a patient by saying, here's how I'm reaching my decision. Please ask me any questions you have about that. Yes, we use this model. It turns out tons of tests and medicines are already black boxes. We don't know how Tylenol works. So we can't get informed consent about how Tylenol works either because we don't know. So it's part of explaining our uncertainties and letting them ask questions. So I think, but that doesn't mean you don't have an approach where the model interacts with patients. It's that the model interacts with me as if I'm a doctor and I interact with patients. Yeah. Yeah, good. I think, so there's two things to balance. Here's a kind of liability you might care about. I want to hold the right party responsible. That's one kind of liability. Another kind of way you think about liability is, how do I set up incentives to make sure we get the best outcomes? And I think in this space, that's just largely the right way to think about it. So let's set up the liability scheme in whatever way is going to result in less mistakes, more well-developed AI, less safety accidents, things like that. So we're just going to specify who's going to be able. We do this in automobile insurance, right? It's like, no, if you rear end someone, you're just in trouble. It doesn't matter what excuse you have. We should do the same in AI. We should ask legal scholars and economists and whatever, I don't know, that's like a really hard problem, that's not my domain. What set of laws would incentivize companies to build better, safer systems? Whereas like you don't want to make all the responsibility on them because then they might stop developing stuff that would be really good. But you might want to have a pretty high level of liability on them because it'll incentivize kind of safety. So for me, it's a total practical question of like, what's the right liability scheme rather than the hard responsibility question like, who's actually at fault? That's an interesting question, but I don't think we should let it dominate in this case. Thanks.